We're going to end strong here. Rob?
Let's hope so. Can you hear me?
Yes, I can hear you. Quick
That's
introduction there. Welcome to
Okay.
Barbados.
Thank you. Sorry, I'm not there with you.
Even if you're here virtually,
Yeah,
we will
indeed.
send you a rum. We're having rum punch after, so we will send you one.
Very good. Well, I have started on the beer already. It's Friday night. It's Friday night here, so.
All right, quick introduction. Rob is a partner at Bureau Happold and started work on, sorry if there are any Arsenal fans in the house. He started work on Tottenham Hotspur Stadium in 2008, and he's here to tell us all about it. Take it away, Rob.
Thanks very much. Well, no, thank you for that introduction. Like I said, it's Friday night here. I'm not actually sat in Tottenham Stadium. I'm sat in Bath in my office, but yeah, I didn't think I'd subject you to that. So yeah, first of all, apologies I'm not in the room with you. I'd love to be there. I'm having to wear my glasses because I'm looking at a few notes here. I don't know, is my head on a screen somewhere? Can people see me? I'm assuming they can. Yes, no? Yeah, okay, I'll keep going. So yeah, so sorry I'm not there, but in not coming, I have saved some of my carbon footprint, which is always a good thing. So yeah, so today I'm going to talk to you about the new Tottenham Hotspur Stadium. I think as has been mentioned, it did win the 2019 iStructE Supreme Prize. And I think as all the footballers are heading off to the World Cup soon, it's not a bad time to sort of pause and reflect. And this stadium, I think, really has become the kind of the new benchmark for stadium in the UK and Europe, or certainly until we build the next one, which we'll come on to in a bit. So I'm going to give you some insights into the challenges we faced and the innovations we introduced to develop the structural design at the stadium. We'll take a look at some of the high-level drivers. I'm going to talk about value, but also a bit of technical detail, as I'm sure you're interested in some of that too. So I've tried to get the right balance here of kind of overview and high-level stuff with a bit of detail, but obviously in the 40 minutes or so we've got, I can only cover so much. And hopefully, I think at the time there'll be some time for questions, so I can answer any of those at the end. Or I'm not sure if there's another presentation to go, but yeah, we can answer some questions. And I'll also show you where to find a bit more detail if you want a bit more technical detail after the presentation as well. And then to finish, sort of picking up on the theme of the conference, I'm going to take a bit of a look forward and ask some broader questions around the justification for future sports stadia. And in particular, given we're in a climate emergency, is it right that we've spent £1 billion and over 150 million tons of carbon, to build something that only hosts a football match every 2 weeks? So I think an important question to ask. So we'll come on to that at the end. So yeah, before we start, I'll introduce myself again quickly. I think that was all in the introduction there, so thank you. But yeah, I'm a partner at Bureau Happold. We're an LLP, limited liability partnership. So yeah, I worked on this project for over 10 years. Started off as the project structural engineer. I led the structural design throughout the project. But by the time we got to construction, I was the project director. We had over 100 engineers of all disciplines working on the project. And there was over 3,000 operatives working on site at the height of the construction. So I now lead the sports sector in the UK for Bureau Happold, with an amazing portfolio of clients you can see on the screen, delivering some amazing venues. So if you just indulge me a little bit at the start here, I just want to give you sort of my personal story on why I do this. Why engineering, why sports, and what was special about the Tottenham project for me. I mean, I've been lucky enough over the 20 years of my career to work on some amazing projects, some of which you can see here on the screen. You know, I love designing sports stadia. You know, I love getting them built. In particular, as a structural engineer, I don't think you can beat it as a sector. You know, there's lots of complex geometry and challenges, lots of structure on show. You know, very rarely gets hidden away in finishes and in wall cavities. So I find it, you know, really satisfying as a structural engineer. And there's not many other sectors you get to see your project host world records, or you get to see them on TV every week. So for those of you who don't know, Match of the Day is a weekly highlights program in the UK, presented by this chap Gary Lineker, who was an England footballer in the 80s and 90s, and I think fast becoming a bit of a national treasure. But in the early days of starting to work in the sports sector, a mentor of mine, a chap called Jeff Warren, he led the team on the Emirates Stadium. So I have got Arsenal in there for you other North London football fans. So when I started, he said, if you're going to see your project on the TV every other week, you better make sure you get it right. So that's something I've very much taken to heart. And for me, Tottenham really has been my Everest. You know, the pinnacle of my career to date. It was over 10 years of my life, and you know, a once in a lifetime project. You know, with a stadium like this, we really are creating something lasting. You know, contributed to a venue that hosts some amazing experiences, which hopefully I'm going to give you a bit of a taste of now. So hopefully the sound is playing on this. I think I've pressed the right button. But this was the opening match at Tottenham that I was lucky enough to go along to. We also play NFL at the stadium. So again, this was the first NFL match, and we'll talk a bit more about that later. And then this was the first rock concert at the stadium. So I think Axel did have a bit of a sore throat that night, but I have to admit that the rubbish singing is me, not Axel. And yeah, a bit of a confession, I am a massive Guns N' Roses fan. So seeing Slash, my all-time guitar hero, playing in my stadium, yeah, it was very emotional. So an amazing place. So hopefully from this video you can get some sense of what it's like to be in the stadium. 60,000 other people. You know, it's quite an experience. So hopefully you got that. But much as I loved those events, really it's about, you know, being proud of what we do. I was very proud to take my family to that first game, proud to show my kids, and proud of what we achieved as an engineering team. As engineers, you know, we create things that we share with others, and that's what I love doing. I love it. So that's enough about me, and you might have to indulge me a bit more at the end, and I'm going to come back to my kids, but. For now, let's talk about Tottenham. So the main reason I'm here today is to talk about the project, and firstly, a bit of context. So here we go. This is the architect's CGI of the development. So on the left-hand side, there's a commercial building called Lily White House. This has got a college in it, some offices, supermarket, and car parking. There's a stadium in the centre there. And to the right, in the foreground, there's the club shop, and behind it, some commercial buildings. The commercial buildings at the back we haven't built yet, so there's a hotel and some tower blocks. And this sits in a master plan. So with most of our major sports developments, the stadium acts as a catalyst, and in this case, driving, you know, regeneration of the whole area over the next 20 years. That should transform this area of North London. So that has some social value. And as most sports clubs, Tottenham really is heart of its community too. So this area of Tottenham is known as White Hart Lane, and it's been the spiritual home for the club for over 100 years. This drove a really strong desire from the club to stay at White Hart Lane and to be away from home for as minimum time as possible. So what this meant is a key driver to the design was phasing. A strategy to keep the club playing at White Hart Lane for as long as possible. And what you've got on the screen now is the footprint of the old stadium in blue over the new one. And here you go, the comparison of size. So the number one there is the old White Hart Lane. So this is number two is the new Tottenham Stadium. And this is why we're doing it: increasing capacity, increasing revenue for the club. But also know how compact it is compared to Wembley. So Wembley has 90,000 seats, at Tottenham with 62. But look how much, okay, so there's more seats at Wembley, but look how much closer we are to the pitch. So this is where we were before we started. So it was light industrial across most of the precinct, and then the stadium up there on the top. This was at the start of excavation, with the stadium still fully operational. And note there the last ransom plot in the middle. Here we are 2 years later, close to the end of what we called phase one, which was building around the existing stadium. So nearly a year of that was taken up with the compulsory purchase order of that last ransom plot I showed you on the previous slide. And the stadium was full operational. So this, we really did go for it on the phasing. So this is one of the cores being built through the top corner of the old stadium. So desperate were the club and the fans to stay at White Hart Lane right to the bitter end. And here we go, 18 months later, or 2 years later, after playing away from home, actually at Wembley for 18 months, and it was complete. But how do you get to Tottenham? There's a very dated transport infrastructure around Tottenham. For those of you in the room who don't know where Tottenham is, here you go. So London in the UK, North London, and they're the transport links that link into this area. And here it is in relation to like I say, the underground rail links. And one of the key things is the stadium's in a bit of a transport shadow, so it's not easy to get to, and that's why it's one of the most the more deprived areas of London. And again, this drove some of the key drivers for the project. Why should people come out to a new, bigger stadium? You saw how much bigger the new stadium was, and this was a key challenge for the whole project. And the answer from the club and the chairman Daniel Levy was simply, it just had to be the best. Build it and they will come. And that's hopefully what I'm going to show you. So, having spent over 10 years of my life working on this project, I could talk about it for hours, but in the time we've got, I'm just going to focus on three key aspects, which will hopefully give you an insight into the design that we created and the value we can create as engineers. If we just pause momentarily there just to consider what we mean by value. This presentation is based partly on a paper I wrote for the iStruct. which was about the value of engineering. So if we define value as benefits minus costs, and engineering has a lot to do with minimizing costs or minimizing material or minimizing carbon or all of these. If we can do that while we're helping to create benefits, we can see how as engineers we can create value. Or to put it another way, as Ted Happold, who founded our company, liked to say, I think he was quoting an American industrialist, but he defined engineering about doing for $1 what any fool can do for $2, and that's the theme we'll be repeating. So the three benefits I'm going to talk to you about are the column-free spaces, the sliding pitch, and then the cable net roof. So I hope you're all doing okay, and you're still with me. I'll just have a bit of a sip. Oh, that's better. Mouth's getting a bit dry. So like I say, let's start with these column-free spaces, and this is the first client benefit I'm going to talk to you about. So this is the West Down section. Part of why the project took over 10 years of my career is we actually did planning twice. So there was a 2010 planning application, which was then altered, but that planning application had already set the height of the building. In the new design, one of the key things was getting more accommodation into that overall section. So what you can see there is a very tight packing of the floors in the overall height, which pushed us down the flat slab route, and we'll come on to materiality in a sec. And the key thing there was around quality. It's about making the spaces as good as they can. It's the concourses drive the revenue. That's where people spend the money, and this was all about being the best. So here's a slice through our Revit model, which gives you an idea of the complexity of that structural frame. And here you go, scale and materiality. So the grey, things coloured in grey, both dark and light, are concrete. The light stuff is generally precast. The blue at the top and sort of wrapping down the sides is the steel. And they're a London bus, just to give you some concept of scale. They don't actually drive the buses on the pitch. I'm not sure Daniel Lee would be very happy about that. And here we are in plan. So to the south, and we'll come on to the south stand in a bit more detail in a bit, it was steel, and to the north, concrete generally. The dark grey sort of long shapes there are the stability cores. So each stability core stabilizing independent parts of the concrete frame. And key reason for this is because we were building around the old stadium. So in that second phase of build, doing it in steel obviously meant we could get it up quicker, or that was the theory. And you can see, you can't see one of the cores anymore. So that was the one that we were building in that corner. And that gave us the phasing line. So yeah, we're going to zoom into that red area in a second. But again, just another story from the chairman, Daniel Levy. So this is the training ground at Tottenham. In the restaurant in this facility, there's a column right in the middle of the restaurant, and Daniel absolutely hates it. So so one of his key challenges was, I don't want any columns in the building, which obviously we couldn't do, but we did do our best to minimise it. So the blue is the original structural grid that we came up with. 7.6 by 8. 7.6 is pretty typical for a stadium. That fits with a normal box width. But here we wanted to push things further. So pushing it out to that wider grid, and we reduced from 20 columns to just 12 in that sort of that bay area. So pushing the grid to 10.1 crossways and 11.6 approximately the other way. What that 10.1 did as well meant that we could have bigger, more spacious boxes again, generating higher revenues. And here we go in section. So the sort of dashed blue lines is where the columns would have been, and the frame that we actually built. And how did we make this work? Well, it was with post tension slabs. So that area that I show you, this is the post tensioning layout in that area. So this is bonded post tensioning, which is what we use in the UK. I think in America they use unbonded more, and I'm assuming that might be what you use in the Caribbean, or maybe you don't use post tension at all because of the environment. And with thinner slabs, you get some dynamics issues as well. So a lot of dynamics that you have to deal with. But in a football stadium or a bowl structure stadium, the bigger issue is actually the seating bowl and the crowd dynamics. So again, trying to maximise the space for hospitality, we will push really hard on some of these cantilevers. Like I say, to maximise the spaces and minimise material. So this meant we had to come up with a completely bespoke approach to dynamics. It didn't work with just the standard guidance that we get for sports stadia. So we had to look at loading the tiers differently. And where we got to is a solution where not all the seats fully met the guidance. So the black ones in that image on the left, and you can just about see it, the kind of purpley covered areas of the main bowl were over calculated limits for comfort for acceleration. But we were able to agree this with building control, and in those areas there's a management strategy which the guidance does allow. That so the stadium management team just have to monitor those seats and offer people different seats if they become uncomfortable. So we did get our frame built and our cantilevers built and got them approved by building control, and the club did get their extra space. And we also managed to do a bit more to reduce our carbon, bearing in mind this was back in 2015 when we were digging this hole, and we weren't yet fully targeting embodied carbon. So I can't take the credit for this, but my geotechnical team spotted this opportunity. What they noticed was, as we were excavating the material, that it looked ideal for making concrete. Oh, wrong way. So that's what we did. We started sorting it and washing it, all that as dug material. Got some good grading out of it. We had to import a little bit to turn it into concrete. We had a batching plant on site, and through that we managed to save a lot of carbon, a lot of cost, and a lot of heavy truck movements. And the concrete we got out of it was so good, we polished it. So this is a picture of one of the main concourses. So we didn't have quite enough as dug material to get all the way up the building. So I think to about level 2 at Tottenham, the floor slabs are all aggregate from the basement we dug out. So like I say, this is the top surface of the as cast in situ slab that then got polished. And what that did is it saved a lot of weight, because we then didn't have to put screeds in and finishes over the top. So it's much more robust. Some of the issues we get on our venue projects is screeds can crack up over time. And the next one. And just to sort of illustrate the point, this is what that space would have looked like if those columns had gone in. So we didn't manage to completely eliminate the columns, but in that shot you can only see one instead of those 4. We also created a column-free area in the east stand for banqueting and conferences on non-match days. So here again, the steel and concrete split, and our London bus has now driven up into the building, to give you some context of scale. And again, that the benefit of our increased column grid with the post-tension slabs meant we only had to drop out 2 columns and transfer them out to get a sort of 24 by 30 meter space. And we achieved this with a transfer structure over 4 levels, so a combination of a kind of tied arch action and a transfer truss. We had to work through some pretty complex detailing to make everything work. As you can imagine, took quite a bit of time. But what it generated were these open spaces with that transfer truss buried in a plant area higher up. And what the club got was enhanced non-match day revenue and higher value. So by taking on Daniel's no column challenge, we didn't quite eliminate all the columns, as you can see, but we did reduce them by about 40% and help drive real value into the project. So I'm not quite sure how we're doing for time, but hopefully we're not too bad. So next up, the sliding pitch. So this is the second of these client benefits I'm going to talk to you about, and this was about the sliding pitch helping to bring the NFL to North London. So an ambition of the chairman Daniel Levy was always to try and entice the NFL to come to Tottenham. There's a whole load of reasons behind this. Part of that is multifunctional use of the stadium. Obviously, the more times you use it, the better it is for everybody. But also the kudos and the enhanced sponsorship that would generate, and the world attention. So this was Daniel's vision. He wanted to be able to play an English Premier League match and an NFL match in the same day. So this kind of drove the whole performance around how we made this transformation work. A key point to note that the starting point for any venue project is about the field of play and the sightlines. And a key challenge around having a multi-use stadium for football and for NFL is that they have very different requirements on sightlines. So one, the football pitch needs to be at the same level as the first row of seats. But in NFL, the players all stand on the edge of the field because there's only a few of them on the field at any one time, and they have to stand at the edge so they can quickly get in and out for plays. So the front row of seats needs to be elevated by 1.6 meters. So this was the architect's idea. Let's put it all on hydraulics and lower it up and down. Obviously very expensive and very technically complex. So being good engineers and trying to do for $1 that anyone would do for $2, we looked for what had been done elsewhere. So this is the Arizona Stadium. It's an NFL stadium in the US, and here they slide their pitch out. Now here they do it to bring it outside because it's a covered stadium with a retractable roof, but they bring it outside to grow the grass in the parking lot. And that really led us to this solution. So 2 pitches, an NFL one and a football pitch that gets slid out of the stadium. Sliding the pitch is relatively low tech actually, and an order of magnitude less cost than that hydraulic system. But that did then present us with another problem: how to get that grass pitch out under 17,500 people in the south stand. That was a 90 meter span, and we talked about dynamics already. You know, a 19-meter span with that many people jumping up and down, it just didn't work. But Daniel doesn't like no, and wouldn't accept the answer, so we sent us away to think again. And the innovation that we came up with was to split the pitch in three. You know, this was relatively simple, gave us a couple of lines of extra support and got over the dynamics problem. But this had never been done before. So in splitting the pitch, like I say, we get extra lines of support. You know, lots of transfer structures required, and again, an even more bespoke approach to the dynamics. And again, splitting the pitch, you know, did add a level of complication. It was more complex. So we spent nearly 2 years doing both you know, computer prototyping and prototyping out of the training ground. Key aspect of this was how the grass pitch joins together. Obviously, you've got very expensive football players running around on the pitch. You don't want them breaking an ankle. And this is the final solution. So on the left there, the red lines picking out the transfer trusses, and then 2 large structural trees at the back. With the transfer structures, it also made it quicker to install on site. So bigger lumps of steel that we could bring in. Huge amount of complex engineering, like I say, in the time we've got, we can't really go into the detail there, but lots of modelling, lots of working with the steelwork fabricators, server fields. Obviously, complex construction sequence, tying things together, but you know, it really has become a key feature of the South Stand. Splitting of the pitch also required a lot of automation around the edge of the pitch. And also we had to work out how to keep the grass alive when it was under that South Stand, so no sunlight. So there's a whole network of specialist lighting. Also have to water the pitch. You know, grounds can get for football pitches get very twitchy about mowing their grass. They need to mow at least every other day. So huge challenges there as well. So while all these measures did add cost and complications, ultimately that was offset by the commercial benefits that I talked about at the start. So again, you know, the engineering innovation that we brought, you know, turned Daniel's NFL dream into a reality. He got his deal, and again, you know, the engineering really helped to create value for the client. So on to the third of our client benefits. So the cable net roof. So again, you know, the structure, the tree structures in the South Stand and other aspects of the stadium, you know, structure really became the architecture. Again, looking at this whole, you know, making this you know, the best it can be so that people would come. So as like I say, the trees were a structure as architecture, but really the cable net roof has become almost the branding enhancing part of the project, as hopefully you saw from that video at the start as I panned round. You know, it's a key element of the stadium, a key part of the experience of sitting in that seating bowl. But how did we get to this point? So as ever, we start with fat pens and scribbling out designs. You know, the roof of a stadium is arguably the key structural element that we designed. So again, this was a bit of a legacy from the 2010 planning application, where we had a bending structure solution, and these were some of the options we're looking at of converting that into the new shape of the roof. So we spent a long time on that bending structure roof. You refined it, presented it back to Daniel, and we had a problem. One of the key innovations that the architect Populus brought was hospitality spaces at the back of the upper bowl. So these are usually quite utilitarian spaces. So it was a bit of a stroke of genius to turn these into high revenue prime hospitality spaces. But this was the problem. If you've got hospitality spaces right at the back of the upper bowl, you're looking straight into the roof. And when we showed Daniel some of these pictures, he wasn't happy. It looked too messy. So the engineering innovation that we bought was to go with a cable net roof, which is the picture on the right. So cable nets usually become effective around over 45 meters. Obviously, there's a lot of sort of variation that can happen in there. And by the way, those costs on the left are a bit out of date now with the cost of living crisis and everything else. Oh, clicked on. So for those of you not familiar with how cable net roofs work, it's a bit like a bicycle wheel. So you take a bicycle wheel, you scale it up by 285 times, you put a hole in the middle, and then you fit the shape around the structure that you've got below, or we did in this case. So all that manipulation is highly complex. It not being circular obviously adds a whole load of complication. Extensive nonlinear analysis. We could do a whole talk just on this. But the basic principles that of a bicycle wheel still hold. So on the left there, you see the rim, which is a compression ring that resolves all those internal tensions. The wheel hub is formed by two tension rings. So those are those things circled in the center there. And they are held apart by rigid steel. And then you've got lower radial cables, so they resist all the gravity loads, and so it's slightly larger, as is the lower tension ring. And then the upper radials or spokes resist all the net wind uplifts. And that's the final roof geometry. So the inherent benefit of tension structures is that tension members don't buckle. Therefore, they can be lighter and more efficient. And given that 60% of what a long span roof is doing is just holding itself up, this obviously has a big advantage. So then we take a bicycle wool and we clad it and integrate it into the overall structure, and there you have your roof. So the one drawback that you do have with cable net structures is in the construction. So in the erection sequence, it has to happen in a very prescriptive way. In particular, you need the perimeter compression ring there before you can start lifting the cables. And as you saw in our phasing, we had to get the south stand in. The south stand, which was that big steel structure, the south stand supported that compression ring. So that was one of the key milestones and drivers for the whole construction sequence, getting the compression ring complete so we could lift the cable net roof into place. When you get to that point and start lifting it, it only takes well, a few days really, but it's done in stages, so a couple of weeks, and the roof goes from the ground and it's fully lifted. One of the advantages that gives you is that you don't need lots of false work. So if I show you the Emirates Stadium, where we had a bending structure, there was lots of temporary towers, etc. So cable nets, are very efficient in terms of being able to lift them up into place and jack them into place. So Daniel got what he wanted. This is the enhanced view from that hospitality space at the back of the upper bowl, and we got a highly elegant roof on our stadium. So the value here is obviously multiple, but I think the roof really does provide that sort of dominant architecture for the inside of the stadium. So that's it in terms of the detail on Tottenham. I have to finish with a few acknowledgements. As with all of our very complex projects, it's a massive collaboration of lots of firms. In particular, picking out the club, Tottenham and particularly Daniel Levy really drove the vision for this all the way through the project. The architects populace, obviously highly involved in the vision, and Slight, Bergerman and Walsh for the detailed design of the cable net and the PT frame design, and then Severfield on the steel, and Morris Rowe on the concrete, who we worked very closely with on site. As I said at the start, we won the Supreme Award and actually the Longspan Award at the 2019 awards evening. So I'm very proud of the engineering we did. Like I said, if you want more detail, I did write a paper, and there is a bit more of a technical talk on the iStruct website as well, so you can go and have a look at those. And the stadium has won wider acclaim. NFL mode in particular has been very successful. The Raiders quarterback Derek Carr even labelled this the best stadium he's ever seen when he played in the first match there back in 2019. Praise indeed from an American, given the wealth of NFL stadiums they have in the US. Yeah, so I'm immensely proud of my personal contributions to this. Like I say, it has been my Everest project, and I'm really proud of what the BH team achieved with this amazing stadium. But at the start, I did promise that I would talk about the future as well and link this into the theme of your conference, and also said I'd come back to my kids. So proud as I was to take my family to that opening batch, what I think we all really want is for our kids to be proud of us and what we do. So my youngest daughter, Jessie, see her in the front there, she's passionate about two things. The first one's football. She's played football ever since she's seven years old, and dreams of playing for England and the Lionesses. But she's also passionate about the planet. So this year she stopped eating red meat because she was really worried about what methane from cows was doing for our climate. And climate change is here, isn't it? This was a picture you might have seen on YouTube from back in February this year, where we got 100-mile-an-hour winds in London. Don't worry too much. This is a cable net roof, so we expect large movements, but this is starting to get towards the maximum of what we've designed this for. So, at a very practical level, do we need to be looking at, the wind loads that we design for in future stadia? And I see from the conference that's something you've been discussing as well. But at a more fundamental level, should we be building stadiums like this at all in the future? As a stadium designer, you'd expect me to say yes, but it does keep me up at night thinking about and worrying about things like this, particularly given my daughter's passion for it. So I'm not sure I've got the answer, but I think it is the question we need to ask ourselves as engineers and as an industry. So back to the question I posed at the start, given the climate emergency, was it right to spend this much money and this much carbon on something that we only play football in twice a week? I think the first thing to say is we don't only play football in it twice a week. As you saw, we play NFL. Sweating the asset, as we call it, is key to maximising the revenue. So they are used a lot more than that. And if we go back to our value conversation, defining value as benefits minus costs, we do have things on on either side of this equation. I'm not sure they necessarily balance, but there are points on both sides. And I think on the cost side, those are all they're all real, but they're all things that we can do something about. So I would argue that we shouldn't eliminate new stadia, because if you eliminate them, you don't get those wider benefits. But I think we do need to do all we can, to reuse, reduce how much we build, specify better to improve our embodied carbon for the bits that we do build. But this needs us all to act, and a conscious effort to do so. Nearly finished. So the football clubs. This is what Tottenham are trying to do. With looking at community and sustainability. I'm a little bit dubious of sports clubs around this area. And I don't want to endorse greenwashing. But I think these are genuine attempts to do better, engender better attitudes, and they do have an influence on their fan base. So I think for that they should be commended. And as a sector, as I said, and a profession, I think we have to question ourselves and strive for efficiency. Make sure that we push for rationale over whimsical decision making. As Bureau Happold, we are setting ourselves targets and measuring what we do. I think we've got a long way to go, but we do have a route map for improvement, and we're investing a lot in technologies and bringing these together to implement onto our projects, to be more efficient, and as I say, try and do for $1 what any fool can do for $2. And obviously, the institution is doing what it can as well. One of my colleagues attended this event not so long ago, and obviously, you've all been talking about this over the last 2 days. So we've only scratched the surface, really, of both that subject and that my 10 years on Tottenham. But hopefully, that's given you all some insight and understanding, and I hope some of my thoughts at the end there have helped contribute to what you've been talking about over the last 2 days. So I think if you take, remember nothing else from this presentation, I think remember to articulate the value that we bring as engineers, and strive to do more with less. And that's me. Thank you very much.